Assalamu alaikum wa rahmatullahi wa barakatuh. This is Marwan Shweki, the Planetarium Director in the Sharjah Academy for Astronomy, Space Sciences and Technology. Welcome to this journey through the universe. In our journey in this virtual planetarium, we'll start from here, from the UAE, and we will go to where? To the sky, to see how the universe would look like if we travel to the skies. In our journey, we will not use any rockets. We will use our virtual planetarium. So you will be on board. Welcome on board. This journey will be a special one because we will talk about the main milestones in astronomy evaluation that actually was actually done by great astronomers. And you may know Galileo, you know Newton. Galileo, the first man who actually studied the sky by telescope. The ancients, they did study the sky, but without telescopes. With actually what they did, they used their eyes, the most important telescopes, if we can, or to see without just telescopes. And they used special instruments to measure the distances between the angular distances or separation angle between the objects. They developed actually different tools. We will see also maybe one of them is Maryam, the one who actually developed one of the mothers of the astrolabes. And actually also we will not talk about Newton or Einstein or all those who developed astronomy, the male ones. We will talk about the female, the ladies who actually played a great role in developing astronomy. Who are they? Please just be with us in this journey that we will go through it, by which we will go to the outer space, and we see what those astronomers, female astronomers, did and developed astronomy. Before that, we would like to talk about our sky. What can we see these nights from the UAE? Now you see here the sky of Sharjah. This is here the west, and we see the sun has already set at this time. This is real time, by the way, here by pressing here, that gives the real time actually. No, this is not Sharjah. So I need to go to Sharjah. I was simulating somewhere else. Very simple. We just go here. We write Sharjah. Okay. And we choose. This is Sharjah actually. And we need to use Sharjah as default. That's it. And here we go. So this is the sky of Sharjah. And this is now. But I would like to go back about 1 hour back. So this is now here time as 1 hour ago. Now time is 8 p.m. but I pushed it 1 hour back. This is the advantage when you use such softwares. This software, we have to mention this software. This software is really great one for all those who would like to learn from the sky. For those, for astronomers, for amateur astronomers as well. Why? Because it helps everyone to see what's going in the sky, or to see what's going in the future, or to see how the sky would like from, not only from your location, any place on the earth, even any place on the other planets, believe it or not. we may do that, but please stay with us. Actually, this is the west, and the sun has already set. We can push time here, the minutes. We can also push time from here. This I forgot to mention this one. This one is called actually stellarium. We have to mention this one. This is stellarium. It was developed by people, very good people, as I always say, who actually do this as free source. Everyone can use this. I really appreciate this software and those guys who look after this planetarium software. This is Stellarium. You can download it for free from the internet, especially if you use it on your laptop or desktop. If you would like to download it on your mobile phone, I think you have to pay something very small amount, simple amount actually, because maybe they have to pay for the Google Play and Apple Store. This is why just to cover those things. Anyway, so this is the sky. You see here our moon. Look up. If you go now, if you can just look through the window, you'll see the moon, which is today is half moon. So let me just zoom into it. So we have our own telescope now here. Wow, so this is how the moon looks like. Wow, it is not dark enough because I am simulating the sky as it was 1 hour ago. So as we push time forward, so the sky gets darker and the moon, and you see the stars even. Look, you can see the details in the moon. If you have a telescope, you'll be able to see those craters and those Maria or the seas of the moon. That's what the first what Galileo saw when he used his small telescope about 4 centuries ago. Okay, let's go back to that time as I mentioned. Okay, time now. Yes, this is the whole sky, you see, and I will push time forward. Okay, look what will happen. Wow. Now this is the twilight, and you can see the stars here. The moon, of course, is there. This line, maybe you see always there. That is the ecliptic, where the sun supposed to apparently move in the sky from season to other season, from day to day. Not the daily motion, by the way. Daily motion is because of the Earth spinning around itself. So, okay, now we can see the constellations, 88 constellations in the sky. So this is a beautiful number. By the way, that's the number of the keyboard. If you got a keyboard, the complete one, the grand one, or the upright one. So you get actually 88 keys. I don't know what harmony is there between the keyboard and the music and the number of the constellations. Anyway, I'm joking because the number of constellations is something that we decided, depending on many historical and mythological facts in the past. So just the number is the same, 88 constellations. But I guess you know 12 of them, right? Do you remember your zodiac or your sign? That the way that not we, but the astrologers name. So we don't say the signs, we say the constellations. But they actually focus on 12 of them. Those 12 signs actually, to the astrologers, not to the astronomers, they somehow try to tell you I mean the astrologers, they can, by using, I don't know what they call, not science, but definitely not science. So they tell you your future. To me, I don't believe in that because the stars are very, very far. We can simulate that. Yeah. Okay. So now, uh, so the beautiful sky, we look at south now. Here, south, north is there. We can see the Big Dipper here. We can see here the dragon. You can see even the Big Dipper here, the Little Dipper, the Big Dipper here. You see Arcturus, very bright star, this one here. And you can see also another bright star, which is Spica. But here, the moon is there and so bright. You see different constellations everywhere. This is Leo. Wow, beautiful animal. You see a Virgo, and the bright star Spica is the brightest star in Virgo. You see here Libra, and you see here what? Beautiful constellation. Try to guess. Wow, look here where it stings. Wow, so this is Scorpius, exactly, the scorpion. And you see Sagittarius. And this is a beautiful one, which is called Ophiuchus. This is Hercules, or the man who is dancing. You see many other constellations. This is the Lyra. This is Cygnus, this one, and this is actually Altair. This is star, which is forget its name. Aquila, yes, Aquila, the bird. And the ancients imagined those constellations for something different, animals and heroes of the ancient myths. And you see here how they imagined all of that. Wow, great. So we have drama in the sky by the ancients. So the drama of the ancients, that actually can be considered, or the way I think that can be considered the origin of new drama and new movies that you see in the cinema and on the TV. So this is the sky itself was the first large screen where those beautiful drama had been playing in the sky for the ancients. Wow, look, I'd like to see that. Okay, I will push time forward and see how that would change. I will stop day and night, and you can see here how the sky is moving. I will make it a little bit slower. This is the sun, and when the sun rises, of course, it should be daytime, but fortunately, with such beautiful software, we can even enable and disable So this is how the sky would look like. So the sky is in Gemini constellation. Every month it actually traveled about 30 degrees in this line, which is the ecliptic, the path of the apparent motion of the sun, and the moon is here. Okay, so now we would like now to know or to see the how those stars have been classified, what efforts have been put on astronomy to study the universe, to study the planets, to study the galaxies and the stars, in particular the stars. So not only male astronomers who developed that, there are many ladies, many female astronomers. I guess you can at least maybe remember one of them. If not, let's now invite also a female astronomer, Fatima Al-Khatiri, scientific guide in the planetarium in the Sharjah Academy for Astronomy and Space Sciences. Fatima, how are you?
Hello, Dr. Marwan. How are you?
I am good. So we are waiting to tell us something about what the ladies did or how they actually developed astronomy. And I guess because you are also female astronomer. Maybe you can tell us better. So, what do you think? I see many ladies in the screen. So who are those?
Okay. Good evening, everyone. I'm so happy to be with you today in this show, and I would like to thank Mr. Marwan for this invitation. Today, I'm gonna talk about women astronomers who made history. And actually, I selected 9 women astronomers and one physicist and chemical scientist who won the Nobel Prize twice. And I see that these 9 women astronomers, 4 or 5 of them should have received the Nobel Prize, but didn't because
Not good, not good. Why? So there is something wrong being done in the Nobel Prize guys. Those who give it. So why on ladies they rethink? So something wrong is taking place. Do you think?
Because there were women and Nobel Prizes were awarded that time just for men.
Oh, I'm sorry. I'm sorry. Shame. But that is fact. I think that's a fact. Okay.
Let's start now by the first one, Hypatia. Hypatia, born in Alexandria in Egypt, daughter of Theon Alexandrius, a famous mathematician, and she was one of the first women to study mathematics and astronomy. She was known as the mother of mathematics. Also, she rose to become the head of the new Platonic school in Alexandria.
Wow. Great.
And she was the inventor of the hydrometer. The hydrometer is still used today as a device to measure specific gravity in liquids. And she also improved the design of astrolabe. This is about Hypatia.
Wow. Great.
And now
But
let's
what is this picture? Wow, this is not good. I see here in this picture. So this is, I believe, when she was killed. Killed. Yes, I am. That's real. Yes, I'm serious. She was killed, murdered by actually by drag. She was dragged on the street by those men who thought she was walking against the church. So they just killed her. So it was not good way to 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 deal with such astronomer and scientist. So really, when I read about her, I feel very sad. Oh, not good. I'm sorry. Please continue.
okay. Let's move now to Carolina Herschel. She was born in Germany in 1750, and Carolina and her brother William Herschel were before musicians, and they became after that astronomers. She moved to the UK in 1772 with William, and they became both of them interested in astronomy. Uh, in 1781, William discovered Uranus, and at that time, Carolina was 31 years old.
Yeah,
Uh, there is more achievements for Carolina. Carolina developed methods of exploring the sky and studied the binary systems and published important stellar catalogs. Also, she discovered eight comets, and one
Wow.
of them named after her.
Yeah.
And that one was the second comet.
Okay, great. You must love this female astronomer because you call her Carolina, not Caroline. So it's that's okay. That's your way. Okay. Okay, great. Carolina, yes. Herschel. Great, yes. And I remember one thing I can add. She was studying, I think, the what we call in astronomy the nebulae. Nebulae now are very well known to the astronomers, but in that time, about 3 centuries ago, it was not easy to understand, or 2 centuries and half actually, in 1780, 1790. So it was not easy to understand what everything in the sky, because they didn't understand how far they are, and they didn't understand how big they are. So also they didn't understand what they are. So this is why everything looked mysterious, so not easy. I remember she and her brother William, they start to put some theories about what the nebulae are that were at that time. Also, they studied the sunspots on the surface of the sun, the dark spots, and what they thought about that, something really funny. So they thought those nothing but holes that that can show what is below the fire, which is black. The black, dark place down in the fire. So of course that was not correct, but they tried to think about these sunspots. Okay, good. Yes, beautiful. Who are those ladies, Fatima?
Okay, yeah, now we are moved to Harvard Computers. As you know, before modern devices such as laptops, mobile phones were invented, a computer was a person who did calculation and so on. At Harvard College Observatory, between the 19th to early 20th century, several dozen women were computers. And now we will start by Williamena. Williamena is a Scotch astronomer. She was born in Scotland, and she helped developed a common designation system for stars and cataloged thousands of stars and other astronomical phenomena. Also, she contribute to the cataloging of stars that would be published as the Henry Draper catalog. And now let's move to another slide to take a look at Henry Draper catalog. As you can see here in this slide, Henry catalog labeled the stars according to their number. So you can see in this picture, for example, Betelgeuse, a super red giant star in Orion constellation, uh, uh, give this star number HD and number. So this is how Henry Draper cataloging stars by number. And now let's return back to Williamina to see how she classified the star. She labeled stellar spectra with capital letters, as you can see in this picture, according to the width of their hydrogen absorption lines. And she began with A until she reached the B. So she used three alphabets O, B, and Q. She used alphabet O for stars whose spectra consisted mainly of bright lines. And those stars today recognized as Wolf-Rayet stars. And she used P for planetary nebulae, and
Nebula.
nebulae, and
Yes.
Q for stars not fitting into any other of classification. This is how Williamena classified the star. And also she published a list of 222 variable stars she had discovered. Also, you can see in this picture, you can see Horsehead Nebula. She discovered the Horsehead Nebula in 1888. And now I want Mr. Marwan.
Maybe seven. This one, I think, because she worked in that area. 1788, maybe. That's when she was not alive in 1888, maybe. Okay, yes. This is
No,
Williamina. No,
she
Williamina.
live
Yeah, yes,
until
Williamina. Williamina. Yes,
yeah.
yes. You are correct. I thought we talk about the Herschel. Yes. Okay. Yes. Yes.
Because
Yes.
Williamina
Yes. Williamina. Yes.
until
Yes.
1900
Yes. Yes. You are correct. You are correct. I'm.
Okay,
Yes.
you can take us to see Horsehead Nebula in Orion
Okay,
constellation.
so it looks like
Okay.
the horse head indeed. Look here. So
Mm.
this is why it was its name. Okay, so let me take you to the sky again and to see the Horsehead Nebula. I can't see the constellation. This is the constellation. I'll stop time now. Okay, so let's stop here. Go back to the past 2 hours. It doesn't matter the date here because it was running non-stop. And this is the constellation of Orion. So this is a great constellation, very beautiful constellation. And it is one of the very famous and beautiful constellations in winter. Look, it looks like a man who is a hunter having a piece of wood here, trying to he was fighting with the Taurus, the pole, and here this one is his leg, and you see here Rachel. So Rachel is Arabic of leg, and this is Betelgeuse. These are the main stars, the two bright stars. Betelgeuse, Arabic of Bed or Yed al Jawza. So why? Because most of star names are of Arabic origin, by the way, most of them, because of the great role of Arab Islamic civilization in the 11th century and 12th century ago. And what you see here is, look here, I will remove the picture here because you can do everything, fortunately. You can see here the great nebula called M42 here. But if you go a little bit here above this nebula, you see three stars. Those three stars represent the belt of Orion the Hunter, the belt. This is how they were imagined by the ancients. And you see also names of Arabic, al-Mintaqa or Mintaqa. This is Nilam. Nilam actually in Arabic Nizam, but one of the letters was not obvious to the translators, so they thought the to la, so instead of Nizam became Nilam, because the shape is almost close to it for those who understand or are familiar with the Arabic letters. And here we see a great, beautiful picture for nebula beside the star, which is an nitaq. Nitaq, also another name of or hizam or nitaq, which is the Arabic of belt. So here is the one that you are talking about that Williamena found. Please, okay? Is it this one, Fatima?
Yes, Mr. Marwan, thank you for this journey to see Horsehead Nebula. And now,
So for by the way, for those who got good telescopes, not large, I mean medium telescopes, the one with maybe $500 to $1,000, something like this, they will be able to see all of these nebulae, by the way. And if you got good camera, you can take pictures for those nebulae. You can publish them under your name to tell, look, this is the nebula that I not discovered. You just photograph. Again, back to those ladies who discovered more about us. Okay.
thank you, Mr. Marwan. And now let's move to Annie Cannon. Annie focused on the topic of star classification, and she classified stars according to their temperature. She became Beacon's women, which the Henry catalog mapping and defining every star in the sky and cataloging the spectra to magnitude of 9. Annie classified more stars in lifetime than anyone else, about 500,000 stars. And in 1922, her system was adopted by the International Astronomical Union. And this system of Annie Cannon is still being used today with minor changes.
This one, you mean? This one here, right?
Yeah, the last one.
Yes, and this is why it's called canon as well. Canon classification.
Canon
Sometimes,
classification.
yes, not canon. Canon plus someone maybe HC. I'm not sure. Two names I have to check actually because of two guys. One guy and Canon. I think these are named after them. I think because they cooperated work. Okay, good.
And the American Astronomical Society presents the Annie Cannon Award annually to female astronomers for distinguished work in astronomy. This is about Annie, and now let's move to Henrietta Swan Leavitt.
But I love this lady, Fatima. I really love her. Do you know why?
Why?
Henrietta Swan, I remember her name very well. Henrietta Swan Leavitt.
Leavitt.
Yes, because she was behind the great job someone discovered and published. And everyone, and even some kids, know what he did. She was behind that discovery. The astronomers who actually has a satellite, a telescope in the sky, orbital telescope named after him. I believe now all the audience can guess his name. what is the story behind that? So how Henrietta Swan Leavitt was actually a main factor for him, I mean Hubble, Edwin Hubble, to discover the expansion of the universe or the size of the universe. Please tell us. Wow, this is
Okay,
great.
Henrietta, the woman who measured the universe. She is an American astronomer who was known for her discovery of the relation between period and luminosity in Cepheid variables pulsating stars, and that vary in brightness in period ranging from a few days to several months, as you can see in this picture. Today, the period luminosity relation is used to calculate the distances of galaxies. And as Mr. Marwan mentioned, after her death, Edwin Hubble used Lafayette's luminosity period relation together with the galactic spectral shifts first measured by Fisto Slipper in order to establish that the universe is expanding. And as we know that Edwin Hubble noticed that there were billions galaxies beside our own Milky Way, and all the galaxies are moving away from each other.
Yeah,
And
but
this
with different
suggested,
with different technique, of course. There is
mm,
no relation between what Henrietta discovered and the expansion of the universe. No direct actual link,
no,
but
but
she,
uh,
her discovery actually led Hubble to check the distance to the closest nebulae, those dark objects they were considered to be part of the galaxy. But because of her discovery, they discovered, oh, look how far those are. So those actually became different galaxies, not small parts in our galaxy. So this made the universe bigger, much bigger, suddenly in a moment. So, but later with different technique, which is the redshift, happen again, he found those galaxies are expanding, are traveling away from us. That's the
uh,
expansion. Yes, great.
so she opened the way for measuring the universe.
Exactly.
This is about Henrietta Swan Leavitt,
Wow.
and she is a great woman. And now let's meet
Cecilia.
Cecilia. Cecilia actually discovered what the universe made of, and she used actually the spectrum of the light to identify what stars are made of. And she noticed that stars made of hydrogen and helium. But her advisor told her she was wrong. And then, after 4 years later, she reached the same conclusion and took credit for her groundbreaking idea that all the stars in the universe mostly made of helium and hydrogen. And now I see that Mr. Marwan take us to our stars, the sun. This is about Cecilia. And
So we are
now,
traveling away from the Earth, going directly to our star. That is the sun.
and actually, the sun is the main sequence star made mostly of hydrogen, and helium. As you can see, this is our sun.
Wow. Yes, great.
This is about Cecilia, and now let's turn to Vera. Vera was the one to study and discover discrepancy between observed and predicted rotation curves of galaxies, which was the first hint for the existence of dark matter. Vera saw something unusual in the universe, and especially in galaxies. Outer stars orbit just as quickly as those in the center, and she surmised that each galaxy must contain more mass than meets the eye, and it was the first observational evidence of dark matter, which today is one of the most studied topic in cosmology. So also Vera was a great woman.
Yes. And what about Jocelyn Bell? Wow, I know the story of this one. Very, very attractive story. And also, we talk about something wrong happened here when it comes to Nobel Prize.
Uh,
Something happened. So, what?
Jocelyn
So,
actually work with his director Anthony Huish.
mm,
So Jocelyn Bell, Irish astrophysicist, and she was a PhD student at University of Cambridge. She discovered the first radio pulsar with Antonio Huish,
mm.
and
So
as
what are pulsars, do you think? So let's tell the audience something about pulsars. So the dead star. So let me say in 1 minute, pulsars are one of the three main uh, death methods of stars. So stars actually live for millions to billions of years before they start to die. And the death of stars take place in different scenarios actually that actually depends on how massive they are. The lighter the star, the longer they live and give energy. But the heavier the stars, actually, vice versa. So they live shorter. So for the heavy stars, actually they end their lives in supernovae. That's the explosion, very very massive and very huge explosion. So after the explosion, usually the most of those supernovae, they turn into neutron stars. Some neutron stars, they actually spin at very high speed, giving radio waves, very powerful radio waves. Some of them even they have very strong magnet field. They are called magnetars. So this is one. What she discovered was the first ever source of such radio, which reached us as what? As very synchronized and harmonious signal. Beep, 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 beep. Such thing for the astronomers, that means something. There is some intelligence behind that intelligence. Living creatures could be sending something to us. This is what they thought, but later they found no, no, no. Hold on, this is nature object, which is pulsar. This is why. Okay, so tell us how that happened and why she was not able to take the Nobel Prize.
But I want to add that also a pulsar is a neutron star, exactly, or no?
Yes, Newton star,
No,
exactly.
neutron star, yeah. So which was awarded the physics Nobel Prize for this in 1974, while she was excluded from this prize. But in 2013, she was listed as one of the 100 most powerful women in the UK.
Mhm.
And the last women for today, Mary. Mary, as I mentioned in the beginning of the show, she was a physicist and chemical scientist. Um, and also one of the most scientists of her time. She was the first woman to win a Nobel Prize for physics in 1903, and the first person and only woman to win it twice. And the second for chemistry in 1911. Actually, she discovered two elements, polonium and radium, in 1898. And she one of her achievements developed of the theory of radioactivity
Mhm.
and techniques for isolating radioactive isotopes. This is
Okay.
Mary.
Thank
And
you. Thank
now
you.
maybe
But okay, but she was not really astronomer, but scientist who discovered something really great, the
physicist.
radiation and some elements. Yes, exactly. Okay, thank you very much, Fatima, for this brief about the astronomers. But I would like just also to talk about one Arab astronomer who developed some techniques to observe the sky. I would like to invite my colleague Muhammad Hani, also a scientific guide in the planetarium. Muhammad, are you there?
Yes.
So,
Assalamu alaikum.
yeah, I think her
Yes,
name is Maryam. So, who is
yes,
Maryam?
Maryam al-Astarlabiya.
Mm.
Unfortunately, not much is known about Maryam life.
Oh,
More is known about her invention, the astrolabe. Unfortunately, we don't have a big source in the history mentioned a lot of her life. But she lived in the 10th century in Al-Abbasid, Dawla Abbasiyya, under the rule of Saif al-Dawla al-Hamadani between 944 and 67. She was the daughter of a famous astronomer. It was Abu al-Hassan
yeah,
al-Kilani or al-Jili. There is a different transcription about the name of her father. Sometime we name Al-Kilani because it's related to Astan Kilan maybe in Faris.
mm,
And her father was apprenticed. He learned the astrolabe from a maker. His name is Bitolos. The teacher of her father was Bitolos. He was in Baghdad in this era, and she was a pupil also with her father in the school of Bitolos. But the history tells us that she excelled in her field, in the field of astronomy, mathematics, until she not invent, but she developed the astrolabe, because the astrolabe, it was before her,
yeah,
and she developed the complex astrolabe. That mean what mean? That mean we can change all the plate. We know that there is so many plates in the astrolabe. She
yeah,
can change the plate. That mean we doesn't need to change the plate when we are using this astrolabe. Otherwise, no, we have to change every time when we go, for example, to any latitude, any city, we have to change the plate. But here, Astrolabe was complete because we can use it everywhere. This is the really the invention, the good invention of Maryam al-Astrolabiyya.
Really great, really
Yes.
great. So something
Great,
like a software that you can run it in your Apple or Microsoft.
yes, yes, we have
Something
apps
like
now.
this,
Yes,
or on your Apple or Android. So
Android,
it's
yes.
great, great idea. Yes.
And
Okay.
the history also tell us that she left a lot of book, but the famous one, it was The Rise of the Sun, Knowledge of the Horoscope, and the feature of Al-Qibla, of course, the latitude of any country and more.
Yeah.
Also, the main built asteroid 7060 was named in her honor. This asteroid, this 7060 asteroid,
Yeah.
it is the main built discovered by Henry Holt at Palomar Observatory in 1990, but it was named Al-Ajliya.
Yeah.
This 7060 Al-Ajliya in honor for her. And also, she was named an extraordinary woman from the golden age of Islam.
Good
In the
recognition.
book,
Good
yes,
recognition for
yes,
her
in
honor.
1001 Invention. This is a big book.
Yes.
And I heard about her some before 1 week. There is a scientific, her name is, I think, yes. She is titular of character in Okorafor, Nindi Okorafor. She's a science fiction. She is writing a science fiction novel, and her name is Binti. She is influenced by this woman, Maryam al-Astorlabiyya, and she was.
Influenced by her.
Yes, influenced by
Okay.
her, and she was surprised that there was a big woman like Maryam Astarabia in that time. She developed the astrolabe, and
Wow. Great.
she mentioned her in her new novel. She is from Nigeria, I think.
Thank you very much. So this is great.
Okay.
And, I would like, as we are there, to talk about the solar system and the motions of the planets as astrolabe, to imagine them as a huge astrolabe. So this is how the universe, how the solar system look. This is the solar system. I would like now to enlarge the size, the planets to bigger size, and to be able to see. Just a minute, please. Okay. And let's run the whole planets. We see now the planets. They are very close to the planets. You see, is Mercury, Venus, Earth. So maybe it's easier to add the labels to see all planets here. Look how the closer, the faster. And you see here the inner planets. And after the inner planets, we can see the asteroids actually between Mars and Jupiter. Then we see the gaseous planets, Jupiter, Saturn, Uranus, and Neptune. And another belt is there, which is called Kuiper belt. So let me now remove those asteroids and try to speed up the speed up time. Look how fast now we are running. So every second here is 60 days. You make it 100. This is 70. This is 100. So every second here now in the simulator here is 100 days in the reality. Look how fast. Pluto, Mercury is very, very, very fast. Mercury takes about 88 days to make one rotation or revolution around the sun. Jupiter takes 12 years to make one revolution around the sun. Earth, of course, 1 year. So you see the large planets, Saturn, which take about 29 and a half years to make one revolution of the sun, then Uranus and Neptune. So this is the solar system, very beautiful, and the motion is very harmony. Beautiful. Wherever you look in astronomy, you see something really beautiful, and the constellation as well, and everything is influencing us. And wow, it's enough just to see and to do some meditation. When you perform meditation, when you see the motions of the planets, that was actually attracted Kepler, and then by studying the data that his teacher Tycho Brahe did, the observation did, he managed to formulate the three laws of how the planets orbit the sun, and now they are named after him, the Kepler's laws. Wow, this is great, really great. Thank you very much, ladies and gentlemen, boys and girls who are watching the planetarium, the virtual planetarium from the Sharjah Astronomy for Astronomy and the Sharjah Academy, sorry, for Astronomy, Space Science and Technology. I'd like to thank Fatima Al-Khatri for a great lecture about the female astronomers who actually did distinguished in distinguished development in astronomy, and also Mr. Muhammad. Thank you very much, and let's see you next week, Friday, 8 p.m. in Arabic, Saturday, 8 p.m. in English, and see